Hey friends, today I'm going to be doing a super simplified summary of precalculus honors first semester finals review. If you're watching this on YouTube, this is specifically for Mr. Balin's class. The first unit that we covered is functions. I'm going to be going over a couple of practice questions from the quiz in order to cover this. So, this first problem is from the functions quiz version A. If f of x equals x squared plus 3 for -1 is less than or equal to x is less than or equal to 3, what is the range? So this problem is really quite easy. I think that how we should approach this is really just, if that's the domain, then let's plug in those values for x to find what the maximum and minimum value for y will be. So that'll be 4 for the minimum, and that'll be 12 for the maximum. So in the proper fashion of notation, we will be writing that the answer is answer choice E, which is 4 is less than or equal to y is less than or equal to 12. So number 2 is also from the functions quiz. So this is basically one of those problems where they define an interesting different operation, and for this case you pretty much just plug in numbers for x, and yeah. So you'll get that 4 by elimination is the highest or greatest value. Number 3 essentially defines a function for you. In this case, they're using h of x equals x squared plus rad x, and it's basically a composition of functions problem. They're going to ask you to state non-trivial values, and this is pretty much what I got. So essentially, if you plug rad x into x to the power 4 plus x, you'll end up getting what the function of h of x is. So this is concavity, and a lot of it has to do with instantaneous rate of change, but if you don't remember what that is, I suggest doing some individual review for that. So if you guys don't remember what an inverse function is, the definition is f of a equals b, and the inverse of that is f of -1 of b equals a. So essentially in this problem, I'm going to be replacing the x with a y, and vice versa. Solving for the y by itself using algebra is how we're going to go about this problem. And with simple division, moving things over, we'll get that y equals 3x plus 1 over 2 plus x, which is one of the answer choices. So you guys should remember even versus odd functions. It's relatively simple. F of x equals f of negative x for even functions, and f of negative x equals negative f of x for odd functions. So what exactly are the rules for transformations for these guys? Well, I'm just going to be going over the vertical and horizontal shift because the rest of them are pretty easy to review on your own. So if you want to go right 3 and up 2, you'd want to do an f of x minus 3 plus 2. So the first time I started looking over these functions quizzes, the first hole in my content knowledge that I found was the Heaviside function. I remember it being relatively easy to understand, but I had kind of forgotten what the concept was. So essentially the Heaviside function is h of x equals x is less than 0, 0, and if x is greater than 0 or equal to 0, 1. So if we apply the following transformations onto it, what exactly will it look like? Well, we can plug in values and basically find y outputs for them. And by doing that, we'll be able to construct a pretty accurate looking graph as to what this function should be. So right now I'm just going to set up the graph. If you test a couple of points, you'll find that this is what the graph should look like. It'll be an open hole on the bottom for both of the coordinates that it ends and begins at. Another gap in my content knowledge, I would say, is the intermediate value theorem. I had a hard time kind of recalling what this was, but the concept is really quite easy. Let's say you have a negative a, then a positive a, and some values, like I've drawn. So if this is true, because it's a continuous graph, then at the value of y equals 1, there's going to be at least three points where it's going to be like crossing that line. So even though the problem doesn't explicitly say anywhere that it crosses or that it touches y equals 1, we know that by plugging y equals 1 in, we are going to get at least a minimum of 3 outputs. So now we should shift our focus over to polynomials. The first thing that the list of concepts addresses is degrees of polynomials. So right now I'm just pretty much drawing an archetypal graph for 1, 2, 3, and 4 degree polynomials. For the 4th degree one, it could look like that with kind of a squared off bottom, or it could be like this. It really just depends. I hope you guys know how to find this based on the roots, intercepts, and end behavior. It's relatively easy. I think that you guys remember how to do that. Synthetic division is from a while back, but it's pretty easy. And so let's think about Descartes' rule of signs for a second. I've personally kind of forgotten what it is, so let's search it up online. So I personally think that this is a very good picture that describes Descartes' rule of signs, so I would check that picture out if you guys have any questions on it. I'm going to go ahead and skip over the rational roots theorem because I personally don't want to confuse any of you guys. If you're having a hard time with that, I'd recommend just kind of reading over that section of the textbook and make sure that you kind of understand what that is. So complex numbers, I believe, are relatively simple. For this one, we're just going to be looking at magnitude. Essentially, the magnitude of a plus bi equals square root of a squared plus b squared, and it should look familiar like the Pythagorean theorem, because essentially we are calculating distance from the origin, and the plane that I'm using over here is the imaginary plane. part where A is moving is the real side or real axis, and the B movement is the imaginary axis. So let's go over what the law of sines is. This is part of the fundamental trigonometry unit, I believe. So sine of A over A equals sine of B over B equals sine C over C. Or how we learned it in class is sine of alpha over A equals sine of beta over B equals sine of gamma over C. It's a relatively simple equation, and you can memorize it pretty easily. So the law of sines with the ambiguous case is basically, I hope you remember, just a special case where you have angle side side, and the other angle is potentially can be two different angles, and that can really just be you'll know based on basically the other angles that are given to you, and if it's like above 90 degrees, yeah, it's hard for me to explain, but if you need help with that, make sure to read up on it in the textbook. So I just wrote down the law of cosines. I hope you guys were able to remember that. And finally, Heron's formula. Now, I'm not really sure if you'll specifically need to know AMGM inequality, but because we had so many activities on it, I'm assuming you will. So the arithmetic mean is greater than or equal to the geometric mean. And if you guys want to know the definition of AM or GM, I'd recommend searching that up online. So that'll be the end of this video. I know there are a couple of concepts we didn't cover, but I hope you enjoyed it. And if you have any more questions, make sure to ask. Thanks.